We have application also in home automation. So the idea is to connect the home to enhance the energy consumption, or to have some kind of security services and so on. So this is the typical architecture for an IoT system. So IoT, it's about device. So this device can be deployed anywhere, inside the car, on the body, inside the building. This device will be able to connect different kind of information, for example, related to the environment, related to the health, related to the proximity of people, and so on. And all this data will be collected and transmitted wirelessly to a remote cloud platform. So this platform will be in charge of collecting the data, doing some kind of processing, data analytics, and finally to deliver this data to high-level application. And of course, here the idea is to create knowledge based on this raw data. So what are the benefits of the Internet of Things? So here the idea is to connect any device, to connect anybody, any business, using any kind of network. It can be a Wi-Fi, it can be a cellular network, and so on, from anywhere, anytime. And the idea, of course, is to collect raw data. So this data will be processed, filtered, and will be transformed into information. This information then will be translated into knowledge and then wisdom. So some emerging application and challenge. So in nowadays, there are already some IoT application already available on the market. Some typical example is the connected car. So the idea here is to deploy some device inside the car and be able to monitor in real time, for example, a fleet of vehicle, to be able to track those vehicles, to track the behavior of the driver, and so on. Another typical application is the activity tracker. So here the idea is to monitor in real time the physical activity of the people and maybe to propose them some program in order to enhance their physical health. Other application, of course, we have smart outlet for smart building, we have parking sensor, and so on. Yes. Of course, tomorrow we have more exciting application in this area of IoT, and all the urban environment will be actually connected to the Internet of Things. And this is what we call the smart city. So I think there will be a talk talking about that after this talk. So the idea of a smart city is just the ability for all the things which are inside the urban environment to be connected to the Internet and be managed in a centralized way. So of course, in order to reach to that level of the Internet of Things, there is currently still a lot of challenge. One of the biggest challenge is the lack of shared infrastructure or common platform. So currently, company, for example, if a company develop a new solution for intelligent transport system, so this company will develop the whole architecture, including the platform, the device, really optimize it for this application segment. However, in order to have this Internet of Things, we need to have some interoperability. So we need to rely more and more on standard, such that, we can build an application based on any kind of data collected from any kind of device. Another challenge is that the current technology and standard are still fragmented. So there is a lot of standard and technology to build such kind of IoT applications. Also, managing and fostering the rapid innovation is still a challenge for government. Another big challenge is related to the big data. So here it's about data collection. So the volume of the data which will be collected is very huge. And we have some challenge related on the control, how the user can control his own data, how this data can be shared potentially with other users, how to store it, how to process it, and so on. So all these are still a challenge. And finally, there is challenge related to user privacy and security, of course. So just to give you some idea about some market forecast and trend in the area of Internet of Things. So here the opportunity are really big. So we can see that currently the data is growing at 10x. The connected devices are growing also at 300%. And it is estimated that the impact for the company will be around 14.4 trillion US dollar. So really the opportunity are very big. And there is a lot of trend and forecast, and some of the company are expecting to see like 200 billion devices connected by 2020. Some specific forecast related to the Middle East. So the adoption of IoT in the Middle East is starting, and it represents around 2 to 3% of the global IoT market. It is expected in 2015 that more than 25 million IoT devices will be shipped. And the expected growth is mainly in the IoT service, so which is around 50 to 60%. So the main driver are, of course, the telecom operator, the enterprise, the government, and maybe the fastest area or application area in this IoT is mainly related to transportation, automotive, logistics, of course, followed by utility and other application in gas, security, healthcare, and so on. So some standard and enabling technology related to the Internet of Things. So currently, maybe one of the biggest standard which is working in this area of Internet of Things is called 1M2M. So it's a new standard which started actually in 2011, and which is like a group of many organizations, standardization organization in the US, Europe, Asia, and whose objective is to unify all the standardization activity related to IoT and M2M. So M2M is machine to machine. So it's about the communication between machines without the need for any human intervention. And one of the main objectives of this standard is to provide a service layer. So as I said, currently, most of the platforms are really dedicated to certain application field. But in the IoT, we need to have a platform which is able to talk to any device, which is able to enable any kind of applications. So we need to have more and more horizontal platforms, which are generic and application agnostic. And one of the objectives of this 1M2M activity is to define what we call the service layer, which will be responsible for receiving the data, collecting that data, and delivering the data to the end applications and users. Different other IoT key enabling standards exist currently, so including, for example, for the communication protocol, we have MQTT, so it's quite famous in the area of IoT. We have CoAP, lightweight M2M, OMA device management. So all of these are like communication protocol which are standardized and which tomorrow will be like supported by any kind of device. There are other technology more at the MAC and physical layer like Bluetooth, Zigbee, Z-Wave, and Wi-Fi, 5G. All this technology tomorrow will be part of this IoT ecosystem. Of course, in the area of open source, so we can see that there is more and more projects which are open source and free, which started to provide some basic building blocks to enable the development of IoT applications very easily. So for example, there is different things, including Eclipse Paro, which is an implementation of the MQTT protocol. So a lot of projects around this IoT and M2M. And this kind of software, of course, can help the developer to very easily develop a small prototype for IoT. So now I will talk about the Labib IoT platform. So what is Labib IoT? So Labib IoT, it's a new application agnostic platform as a service, which we are developing at QMIC. So the idea here is to develop an horizontal platform which is agnostic, so we don't care about the exact application. It is generic. And the idea, of course, is to be able to collect data from any kind of device using standardized communication protocol, to receive this data, filter it, analyze it, and then store it in the database. And finally, to be able to export or make this data available to the end user to develop specific application in specific application domain, like health, transportation, and so on. So why this need for the Labib IoT? So one of the main target user of this Labib IoT, it's the local entrepreneur in Qatar, the R&D community and research center, and the local enterprise and startup. Let's assume tomorrow you have a great idea and you want to develop a prototype. So using this Labib IoT, you can very easily and very fastly develop a prototype without having to deal with the complexity about how to connect this device to internet, how to understand the communication protocol of that device, how to collect the data, how to store it. So all this basic functionality related to device management, data management, will be somehow provided by this platform, such that the end user and developer can focus on the development of their own or main target applications. So here the benefits are, we have many benefits. Of course, the idea is to have one common platform to enable different applications, to support different functionality and service capability, of course, with the support of standard, which is very important for the IoT. It can enable the user to do fast prototyping with less complexity. As I said, we don't need to care about how to configure a device, how to communicate, how to store the data, and so on. So it can enable faster innovation, rapid time to market. And here the idea is to have an horizontal business model where the user can move from one business market to another one and be able very quickly to test different kinds of applications. So this is our R&D roadmap. So we started a few years ago in 2012. We released the first version of this platform in December 2014. So here we released the first version 1.0. So using that version, we provide different functionality related to data management, device management, and so on. And now we are working, of course, to integrate more technology, especially in the area of big data, like NoSQL database, time series database, and so on. So these are the different features of this Labib Internet of Things platform. So it provides three main functionality. One is related to the data management. So let's assume you have a device and you would like to collect data related, I don't know, to temperature, humidity. So using this platform, you can define the different kind of data model you would like to receive from your device. You can specify filter, different storage option, and so on. And you can access to this data using standardized interface like web service. The other feature is about device management. So here the idea is that you can define your own profile of your device, and you can manage those devices. So you can track them in real time to know if your device is online, offline, if it is malfunctioning, working, and so on. And finally, user management. So here the idea, of course, is to support different enterprise. Each enterprise manage his own device and data, and to have really a certain level of security and privacy for the user. So in order to do that, so in this platform, we implement an application and device agnostic data model. So if we take a typical device, IoT device, which is a small piece of electronic, in this device, we may have different sensors. For example, we may have a GPS sensor, a motion sensor, an ambient sensor, etc. And for every sensor, we may have different data. For the GPS, we may have the altitude, longitude, and so on. So the idea here is that we model this using a generic model such that we can model any kind of device and be able to receive the data and store it.
I'm going to clip your mic. I think it's better if we put it here.
Yeah.
If I can.
OK.
Sorry
Thank you.
that.
And to finish, so this is a few screenshots about this IoT platform. So as a user or developer, the first step is to create and to sign up an account. So you just go there, you create an account, you define the name of your enterprise, and automatically everything will be created for you, the database, everything. Then let's assume you have a device. It can be a drone, it can be a sensor, it can be a smartphone, a Linux machine, or whatever. The first step is to define the profile of this device. So it means you need to define, OK, what is the type of this device? What are the data you will receive from that device? Potentially, you can define some filter. For example, temperature should be between, I don't know, 0 and 50. So to define all the profile related to your device. And then you can add manually, one by one, the different devices that you have in the platform. And the platform will automatically configure all what is related to communication, data analytics, to manage your own device. And finally, once your device is connected to the internet with the proper IP address of this platform, the platform will be able to receive data from that device. And using dashboard, of course, you can monitor, OK, where is my device? You can know if it is currently online, offline. You can know how much data you receive from each device. And of course, you can extract the data. based on different filter, and you can do some statistics and so on. So it's really a platform to make, the development of IoT application much more easier. It will make all what is related to data, device management very easy. And then as a developer and using web service, you can develop your own specific application on top of this Labib IoT platform. So you can develop an application for logistics, for transportation, mHealth, and so on. So this concludes my talk. So if you have any question, yes?